हेलो चिल्ड्रन, आज हम रोटेशनल मोशन चैप्टर का बिट मोमेंट ऑफ इनर्शिया कंसेप्ट को आज समझेंगे। सपोज दिस इज एन ऑब्जेक्ट ऑफ मास m। एक ऑब्जेक्ट है m मास का and this object is revolving or rotating about this axis of rotation. Its distance from here is suppose r, right? It is the axis of rotation. This is the mass m and distance from the axis of the mass m, of course it is 90 degree. Then moment of inertia of this mass about this axis denoted by I is equal to mr square. ये होता है मोमेंट ऑफ इनर्शिया I. This is MOI. It is called, in short we write moment of inertia denoted by MOI, and notation is I, that is mr square. R is the perpendicular distance from the axis of rotation. अगर डिस्टेंस एक्सिस ऑफ रोटेशन से ज्यादा हुआ तो मोमेंट ऑफ इनर्शिया ज्यादा होगा, मास ज्यादा हुआ इन दैट केस आल्सो मोमेंट ऑफ इनर्शिया विल बी मोर. सो इसको हम इस तरह से देख सकते हैं कि इफ नंबर ऑफ मासेस आर देयर डिस्ट्रीब्यूटेड अराउंड द एक्सिस ऑफ रोटेशन, तो जितना डिस्टेंस रहेगा, स्कैटर्ड रहेंगे, मोमेंट ऑफ इनर्शिया उतना ज्यादा रहेगा. डिफरेंट मासेस का डिस्टेंस अगर एक्सिस ऑफ रोटेशन से ज्यादा है तो मोमेंट ऑफ इनर्शिया ज्यादा रहेगा. एक्चुअली ये कॉन्सेप्ट आया कहां से हम बताना चाहेंगे आपको. सपोज आई एम टॉकिंग अबाउट अ सिस्टम ऑफ मासेस, ठीक है, सिस्टम ऑफ पार्टिकल्स. ये एक्सिस ऑफ रोटेशन है एंड वेरियस मासेस आर देयर. एक मास यहां पर है, एक मास यहां पर है, एक मास यहां, एक मास यहां, एक मास यहां. Suppose these are the distances. Suppose it is m1, this is m2, ये हो गया m3, ये हो गया m4, and this is m5 and so on. Number of masses are there. सबके distances हम बोल देते हैं r1, r2, r3, r4, r5. These are distances from the axis of rotation. ये क्या है? It is axis of rotation. The system of particles है. 5 particles I have considered. There may be number of particles, but okay, to understand for the beginning, I have chosen 5 masses. और ये system of particles इस axis के around revolve कर रहा है, rotation. Suppose AB is the axis. ठीक है. अब अगर देखें हम, इफ आई वांट टू फाइंड द एनर्जी ऑफ दिस सिस्टम, टोटल एनर्जी ऑफ द सिस्टम, ठीक है. सो सिंस दीज आर मूविंग अराउंड दिस एक्सिस, सो सबके काइनेटिक एनर्जीज को हम ऐड कर देंगे, ठीक है. सो दैट विल बी द टोटल एनर्जी ऑफ द सिस्टम. सपोज the total energy of these system of particles, system of this system of particles revolving about an axis AB. अब इसके अबाउट ये घूम रहा है. If it is revolving, it must have some kinetic energy, certain velocity is there. So I will write total energy, total kinetic energy. Since it is revolving, we are having kinetic energy only. So for this, its velocity is v1, its velocity is v2, and velocity of this is v3, and this is v4, and this is v5. So total kinetic energy is half m1 v1 square plus half m2 v2 square, likewise half m5 v5 square, right? This is total kinetic energy, right? Actually, if you look at, since all these particles are moving around this axis with different linear velocities, that is v1, v2, v3 and v4, but with a constant angular velocity, this is a system of particles. We can consider that they are connected with each other. There is no relative motion between these masses, so they will be moving with constant angular velocity, but at different distances are there from the axis of rotation, so different linear velocities, because we know v is equal to r omega. This relation we have studied in circular motion. Okay? So we will use that over here. तो हम क्या लिखेंगे, half m1 r1 omega, this is whole square. r1 omega, angular velocity here, omega, that is angular velocity is same for all these particles, since it is system of particles. So whatever angular velocity this particle is having, right, this particle will also be having same angular velocity, because system of particles, there is no relative motion between the particles, right? We can consider it as a rigid body, like something. So r1 omega plus half m2 r2 omega whole square plus likewise 1 upon 2 m5 r5 omega square. We will be getting, here we will prove why it is like this. Here we can write half m1 r1 square omega square plus half m2 r2 square omega square plus likewise half m5 r5 square omega square. From all these, I will take half omega square common, that is half omega square. We can write m1 r1 square plus m2 r2 square plus m5 r5 square. I have considered only 5 particles, but it can be n number of particles. So this will be called as half omega square. This is sigma mi ri square. I is equal to 1 to n. In this case, only 5 I have taken. So in place of n, we can write 5. If there are n number of particles, so it will be extended up to n. Here, if I want to write for this case, so I is equal to 1 to 5. Otherwise, it will be 1 to n. And this quantity is denoted by I, and this is called moment of inertia of the system of particles. That is equal to half omega square I. So here I have taken only one particle, that is why I is equal to mr square. If 5 particles are there, and since it is a scalar quantity, so either this side or this side doesn't matter. All these moment of inertia of every particle will be added, and the total moment of inertia of all the particles of this system of particles. So that is why this is denoted as I, and now it is half I omega square. For rotational motion, this is kinetic energy. So if you remember, I will just compare. This is comparison of, here it is translatory motion, right? Here rotational motion. What is the different terminologies being used? For translatory motion, we get linear displacement. linear displacement is denoted by s. And for rotational motion, there is angular displacement denoted by theta. Here linear velocity v and here angular velocity omega. Here force in translatory motion and torque in the rotational motion. Translational motion, there is linear acceleration and here the angular acceleration denoted by alpha. For force, there is mass into acceleration. So here it is mass and it is moment of inertia. Why? See, kinetic energy, translational kinetic energy is half mv square. Translational kinetic energy and rotational kinetic energy is equal to half I omega square. See this one. Here, for translational motion, linear velocity is being used, v square. For rotational motion, angular velocity is being used, half is same. So here, m in translational motion and I, moment of inertia in the rotational motion. So concept of rotational moment of inertia in case of rotational motion is clear. So we will take some examples. चलो बच्चों कुछ प्रॉब्लम सॉल्व करते हैं, मोमेंट ऑफ इनर्शिया फाइंड आउट करते हैं सर्टेन सिस्टम ऑफ पार्टिकल्स में. चलो पहला एग्जांपल ले लेते हैं. सपोज टू masses are there, both are having mass m. इसके बीच का डिस्टेंस दिया हुआ है 10 मीटर्स. एक एक्सिस ऑफ रोटेशन ऐसा है, दिस इज द एक्सिस ऑफ रोटेशन. This distance is suppose 3 meters. So find the moment of inertia of the system of particles about this axis AB. See, it is very simple. This distance is 3, then this is 7 meters. So moment of inertia is equal to this mass into this, m into 3 square mr square, m into 7 square. So that is 9m plus 49m. That is equal to how much? 58m kg meter square. This is the unit. If it is in kg and distance is square, kg meter square, this is the moment of inertia of the system of particles. चलो भाई दूसरा एग्जांपल ले लेते हैं. सपोज दिस इज अ रेक्टेंगल, 4 masses आर देयर. चलो स्क्वायर ले लेते हैं पहले स्क्वायर. दिस इज 5 5 5 and 5 meters. We have to find the moment of inertia about this axis. How will we find? This is mass is m, mass is m, mass is m and m. So moment of inertia I about this axis. So for this A, B, C and D. So moment of inertia of A is, I will write IA plus IB plus IC plus ID. What is IA? Moment of inertia of this. So distance of this mass from this axis is 0. So IA will be 0 plus. And the square, so it is 90 degree. Moment of inertia of this, IB, mass at this point. I will write mass is this and distance is 5 square. Similarly for C, that is m into 5 square plus again 3. Simple, eh? It is very easy. You can understand. Mass and the square of the perpendicular distance. Similarly for this, and for these two masses, distance is 0. That is, this is the moment of inertia, the system of particles. Right? So ये हो जाएगा बेटा 25m plus 25m, that is 50m, that is kg meter square. This is the moment of inertia. We will take some more examples. In the same question, I will change the axis of rotation. चलो हमने ये axis ले लिया. This is the axis of rotation, and I want moment of inertia of the system of particles about this axis. So it is obvious. इसका IA and IC will be 0 because they are passing from these two masses, and हमको moment of inertia इसका और इसका लेना पड़ेगा. तो drop of perpendicular, since it is a square, so it will be perpendicular and this distance is to be found out. ठीक है, it is a square, तो diagonal क्या होता है बेटा? देखो, AC will be what? In this case, AC is equal to A under root 2, that is 5 under root 2, that we know for a square. किसी भी square के लिए this square plus this square is equal to this square. So AC square is 50. 5 square plus 5 square, 25 plus 25, 50. And if you are taking 25 into 2, 5 will come out. So 5 under root 2 is the diagonal. And diagonals will be of equal length. So this will be 5 under root 2 by 2. This is 5 under root 2 by 2. These are the perpendicular distances. So I will write I of the system of particles IA plus IB plus IC plus IB. IA, this will be 0. What is IB? For that one, so M into perpendicular distance from this axis to this one to 5 under root 2 upon 2 whole square plus IC, again it is 0. ID again M into 5 under root 2 by 2, that is whole square. Okay? So we will just find it out. So M into, these two are the same, so I will write 2 into 25 into 2 by 4. 25 into 2 squaring this, 25 into 2 by 4. So 2 to the 4, 4 will go, that is 25 M kg meter. So this is the answer for this problem. Similarly, many problems we can take. So some more problems I will take in my next video. Till then, all the best. Be happy. Take care.